So once again, I would like to first thank you very much, ngVikings crew, to letting me be here. It's an honor to speak to such a great people here. So I'm going to talk about scalable Angular architecture. So once again, my name is Bartosz Pietrucha. I run Angular Academy trainings. I specialize in Java and JavaScript, so it's kind of full stack. I've held master's degree in computer science, and I've been crafting enterprise software for over 5 years. So we are going to speak about scalable Angular architecture, but the truth is that what we are going to present here and learn are more general pieces of advice how to architecture front-end single-page applications. So Angular is going to be used as an example, implementation example, but the ideas are more general. So let's start. What the software architecture is. Martin Fowler says that this is the highest level breakdown of a system into its parts, or decisions that are hard to change. So what I understand under architecture is how your system is decomposed into smaller pieces, and what are the rules of communication, or what are the restrictions of communication between those pieces working together to serve some high-level goal. So before we jump into this, let's think about how front-end applications scale in general, because it's a different term that when we think about scaling in a back-end application, when you scale up, for example, or scale with more servers, more computing power. In this case, we're talking about front-end application which is working on your client machine, so you don't actually have to have more powerful servers, but you have different problems. Your application is growing in complexity, you have more and more requirements, you're loading more and more data, application could slow down, we can call it a performance degradation. Your team is growing up, rotating, you have juniors, seniors on the team, everybody has the same goal to build scalable, big, large enterprise application. So in general, from my experience, it looks like that in the beginning. Everything is great, there are no many features, everybody understands what's going on and so on. It's very fast. But after some, new features, refactorings and so on, people start feeling that it's hard to actually develop new features and the speed slows down. So what we want to achieve, and this is also my experience, this is not any scientific research, but I believe that many of you can actually feel what I'm saying about that. This axis here is the speed, and this is the time. So if you think about the application that you are building and you don't invest in the good foundations because it's like too heavy, I don't want to introduce so many rules and so on, you are going very fast. But after some time, you slow down your speed of developing new feature, and maintenance efforts are going, the speed is going down and the maintenance efforts are growing. So what we want to achieve is this blue line. We want to be slower at the beginning because we need to build a foundation but maintain our speed over time. So once again, our goal is to have sustainable development speed, ease of adding new features, and maintain the application performance. I'm going to give you 5 pieces of advice how to architecture your app that could help solve problems of complexity, to help you reason about the application, and maintain performance. Before we jump into that, let's be sure that we are all on the same page, because I'm going to be using pretty advanced topics, so I want everybody to be on the same page. So let's introduce a couple of important pieces. Who knows RxJS? Most of you. So I believe this is pretty understandable. We will be using observable term very often in this talk. But if you compare what is observable to a scalar value or an array on promise, this picture shows you actually how it fits into the whole picture. If you think about single value that is available now, you have scalar value. If you have multiple values, that's an array, but they are available right now. What about the things that are available in the future as a result of some request, for example, or some computation, which will be asynchronously executed? Then we think about the promise. But the promise gives us a single value. If we want to have multiple values over time, that's what observable is. It is a stream of some events or changes or values that is provided to us over time, which we subscribe to. This is the simple interface of an observable. So whenever observable emits a new value, it calls next, and the observer is notified about the next value over time. How can we actually implement simple observable with RxJS? This is a small code piece of that. We can see that we are using observable from event API, which builds a stream of events that is going to be sourced by the key up event on the given DOM element. And then we apply a couple of operators like map, debounce. We are doing it in the functional reactive way. We are looking at these events as a stream, and then we apply some function. We use functions to apply some logic on that with any state. We don't use any state, which is functional reactive way of doing it. Last piece, we need to introduce some terms before we actually go in our advices of architecture. State. State is something that we can think of all the variables available to the application in a given time, like list of loaded items, logged user, the state of some profile we actually manipulate of the user on Facebook, whatever it is. So everything that changes over time, but the state is something that is right now available. A view, we can think of this projection. We have a state, the list, the profile, and the view is something that projects this into the graphical interface. So it's like a function of the state to the view. A store is something that we would use to put the state in. So it's a data structure, it's immutable, that holds our state. And then action and reducer. These are the terms from the Redux pattern. Action is something that describes what is going to happen to our store, to our state. And the reducer is a function that takes this action, take the current state, and produce brand new state. So we need to actually be on the same page to start digging into more advanced topic. And okay, who has been using an NGRX store? NGRX store. Pretty much of you. So I believe it's pretty understandable. But for those who are not maybe aware of that, we can think about this like, why would I use a store? Why would I extract something to some state to the single place? There is a nice analogy. Think about your body, and the store is your brain, and my hands could be a component. They have a look, they have a mechanics, but their state is in the brain. And if I would like to clap, for example, I don't want them to communicate. My brain is the central place that holds the state, what should be actually happening now. For example, this is the one state, this is the second state. And then I can instrument the state to actually make components collaborate with each other. So I'm not putting the state in one hand, and because I would need to transform the state or somehow transmit the state to the second hand and then make them work together. I'm using my brain where every information is stored in one place, which gives me maintainability, predictability. And then the synchronization is easier, because if I would have single pieces of the state in different parts of my app, I would need to find a way to synchronize and coordinate the state. We'll see an example later on. And how mechanics of this pattern works. In Redux, you have very simple flow of manipulating and orchestrating these state changes. You just emit an action. You can think of the click and the event being emitted. Here we call it action, that something has happened. And this action describes what happened. Then the reducer, which is responsible for actually taking care of this action, transforms the state and produces the new one. And then this store, which holds the state, use an observable to project or inform every interested party what is the new state, which are our components interested in this state. Okay, so enough for the foundations. Now we are going to our architectural advices. I'm going to give you 5 tips, 5 pieces of advice which you can use in your apps. They work for me in many different scenarios. they could not work for everybody, but you can pick some of them to your architecture in your application. So first, how we divide our application, how we actually structure the horizontal layers in the app. Presentation layer, abstraction layer, and the core layer. What we have here, these are just the components, smart and dumb components that define the view and the mechanics. And then we have application facade, that is the middleware or some abstraction over the core of your app, which has the state management and all the asynchronous services. So presentation layer has very, very, I would say, defined purpose. It presents and delegates to the facade or your sandbox, whatever you can call it, and then say that something has happened, somebody has to take care of it. And it doesn't know how it's done. It's independent of your store, of your API, whatever. It is important that you don't want to put, of course, there can be also some local state. Imagine the situation when you have sidebar and the state of being opened or closed. This is not something that you probably would like to expose to everybody. This is private local state, and you can manage this state locally. So we are talking about the situation right now that you should think which state is private, which state is an application state. In this case, presentation layer delegates application-wide state changes, but maintain its own local states. Abstraction layer. This is something that decouples your UI, your presentation layer, from core layer via API, which you expose. You think of the API, what should happen in this piece of your application, and I can prepare an API that can then be called upon some components. And then I also expose those streams of the states via observables. So I'm sandboxing what can happen actually in this module. I'm not actually allowing everybody to play with all the toys. I'm not allowing everybody to inject the store. I'm not allowing everybody to do everything in the app. I'm just making it actually strict what can happen in this particular module. And the application core logic is in core layer. All the data manipulation, all your reducers or your actions, and the communication with outer world with async services. It also exposes some global services. It has reusable UI components. It can have internationalization and configs and so forth. So that, when it comes to high-level application layers. Then we jump into unidirectional data flow. Take a look at this diagram. Again, we have our layers. This is our core layer, this is our abstraction layer, and this is our presentation layer. And unidirectional data flow says that every action, every event has to go up on the top of our components tree, and the data should flow down so that it's easy actually for the application to understand what changes, what are the bindings changing, and how to propagate all the state and stabilize the tree during the change detection. So on the components level, when we think about Angular, we have inputs and outputs. So this is something that gives us this data flow, unidirectional data flow out of the box. If we build the components like that, when we use inputs and outputs, everything is happening in this way. On the application level, then we need to actually make some effort. We can use some store implementation like ngrx, and then follow the same pattern. Every action, every change, dispatch an action, and then there is an observable. And you, in this facade, you just select pieces of the state that you want to expose. Let's take a look at an example. Here we have a simple app, which is like a master detail view. We have a list and the details view, and the container overlapping all of it. Again, we take a look in the same way. We have three layers: presentation layer, our abstraction layer, and our core layer. And something happens. Somebody wants to promote a given employee. He clicks a button, whatever. I don't care in this case because my UI layer takes care when it should happen. And then I call my facade saying, okay, promote employee. It will call our API, trying to update something on the server side. And then once it succeeds, then it dispatches an action. An application would react because interested parties, interested components, interested pieces of the app are subscribed to observable. So this is like reactive architecture. And here it's easy to exchange this, for example, for Firebase, because this guy here, these pieces here are not aware of what's happening here. It's only very important that only slices of the state are exposed, and API that is exposed to the components is this what presentation layer is aware of. Example of the code in the facade, how we actually, because the facade is actually playing one more role. It synchronizes those two states here. We have like, because you can think of this as a server state and the client state. And you need to somehow make it in sync. So in the pessimistic update, you first call an API. And then if you have success, you need to update your client. So in this case, what you would do, you would dispatch an action. And then inform the user that something successfully happened. But in different case, in the optimistic way, if you, for example, update your UI first, and then you assume that server update would happen successfully, it's okay. But if it failed because server responded with an error, then you would need to roll back this action, dispatching another Redux action, and then inform the user that it really didn't happen because it was an optimistic update. I need to roll it back. So again, here, I'm first calling API, and then updating client. In optimistic way, I'm first updating UI, and then updating client, updating server. So that's it when it comes to data flow. Now think about state management. So this is the part of our application over the facade on the top. Again, in order to communicate with our core layer or change something, we are dispatching an action from the facade, from this abstraction layer, not from the components. And what benefits it gives us? Everything is predictable, every change is described well, and it is propagated in a reactive way that everybody who is interested in the state has to actually subscribe to it. So there could be different pieces in the app that wants to know, for example, think of the Facebook. You have your name everywhere on the page, in the comments, in the top nav, and whatever, and then you change this name. How would you coordinate this change? It's easy to actually just subscribe to a particular piece of the state, and it will be updated accordingly. Otherwise, you would have somehow traverse the tree of components and manage this change to synchronize. So in this case, we have only single instance of the state and projecting that over the interested components. And every module has its own slice of state. But what if you want to share the state? How does it fit into the whole architecture? Here, just a recap that we can use dedicated for Angular management library, which is called ngRxStore. I have already seen that most of you are already using it. But imagine that again we have our layers, and then we have like vertical, because layers are horizontal, modules by features, we can think of like a vertical division. So again, containers or components are not aware of what happens over this abstraction layer. And here, if I want to share the state from different module, I can just, from the facade, call other piece of the store, other piece of the state, selecting this slice of state from the store. And then two last pieces, components. How would we like to make reasoning about the app easier? Smart and dumb components is a well-known pattern how to actually design your components. The smart component, in other ways, container, is something that is composed of those presentational dumb components, It has the facade injected, or this abstraction layer, whatever you call it. It's just a naming. It can be top-level component, but if you think of the example of the admin dashboard, you can have more smart components and create all the view. And the dump components or presentational components are also called pure components, have very little logic. You can think of the button. Like a button has the way it looks, it has an input of the name displayed and the event in case of clicking on it. So you can create your own custom components and then put them in maybe Angular component and use on-push strategy to actually tell Angular that this is pure component. It does not have any sophisticated logic inside. You don't have to change detection over and over every time you run your chain detection cycle. How can it look in the graphical way? Take a look at this example. We have our employee container, which has the facade, or something that is available to communicate with our core layer. And then we have some dump components like the list or item. And we use inputs to put the data down via bindings, which can be then by Angular put it in sync. So this, whenever it changes here, it will be also propagated down. And outputs, in case of the example that we had, that somebody made it, that promotion of the given employee happen, we have an event binding, and we populate this event to the top so that the container could call the facade or your abstraction layer, whatever you call it, and react accordingly. The last part, we want to care about performance. We are growing and growing. Our app has tons of modules, and how we actually organize it. First of all, we are going to use modules to actually pack the particular features, and then later on use lazy loading to load particular parts of the application as we need it. So again, on our architecture view, we have our store actions. There's a typo, it should be state here. Our APIs, facade, UI components, and then other modules follow the same pattern. But they give us a vertical separation. How can we actually organize such kind of modularization? This is what worked for me. This is my proposition. You can actually do this your own way. But I like to put all the async services, like calling the API, whatever it is, HTTP, REST, whatever, in the same folder. Every component, but the presentational component, are in the component folder. Every container, which I know that it is going to be a smart component, has its own folder. All models are in the same directory. This is just one module. And all the state, like reducers, action, and state, are in the state folder. I have this facade, which is something which we call abstraction. Routing, every module has its own routing. And module file. How lazy loading works in practice? We start our app, and imagine that our employee module is our main module. So as the user loads the app is bootstrapped and working, but those modules are not yet loaded. And as we go through the app, additional modules are loaded in the lazy manner. How to achieve it in Angular? It's fairly easy. When you define your routes, you just use load children in your main routing config and put the path. And you should also remember that you need to remove all the imports from other places in your app to this module. If you leave employee module as an import in your app, then it doesn't make sense, because Angular would, when you bundle, Webpack would bundle, for example, Webpack would bundle this, and again, it will end up in one big bundle. So you remove all the imports and place the dependency in load children. Later on in the routing module of the lazy loaded module, you use relative paths, and that's it. All you have to do. This is like an opt-in, opt-out feature. You don't have to change anything in your app. You just change the configuration a little bit. Last part, I have something which is called preloading strategy. So if you run your app and everything is there lazy loaded, user goes to a different module and there is some time, some delay before this module is loaded. So we can actually preload it. So after application is bootstrapped, in the background we can preload other modules. For that we can use preloading strategy in the routing configuration. Angular by default has two strategies. Preload everything, preload nothing. You can build your own strategy. Here I have implemented selective preloading strategy, which will look at this data here, and if the predicate is true, it will preload it. How should I implement this? It's a simple interface preloading strategy. You implement preload, and based on checking the predicate, you say yes or no, should I preload? Should Angular preload this module? Thank you very much. This is the end.